Okay, so on the first one, complete the following table. For kPa, I took 680 torr times 101.325 kPa over 760 torr and got 90.7. And then for torr, I took 680 times 1 torr over 1 millimeter of mercury, which equaled 680. And for ATM, I took 680 times 1 ATM divided by 760 torr and got 0.895 ATM. For the second one, suppose a gas has an initial pressure of 2 ATM. What happens to the pressure if the volume is doubled? Increasing volume will decrease the pressure and it will double. Suppose a gas occupies 1.5 liters at a certain temperature and pressure. What happens to the volume if the number of moles of gas is tripled? Volume and moles are directly proportional when temp and pressure remain constant, so volume will triple. Number 4, an ideal gas sample occupies 1.5 liters at 25 Celsius and 741 millimeters mercury. How many moles are there in this sample? So the first step, I took 741 torr equals 1 over 760 atmosphere to get 0.975 atmosphere. Step 2, I changed Celsius to Kelvin to get 298 Kelvin. Let's see. Then I use PV equals nRT. 0.975 times 1.5 liters equals moles times 0.08206 of the standard and 298 Kelvin, and that gave me 0.50598 moles. What volume would the gas sample occupy at STP? At STP, 1 mole of ideal gas has a volume of about 22.4 liters, so 0.0598 times 22.4 liters equals 1.34 liters. The equation that relates density of gas to molar mass is D equals MP over RT. What is the molar mass of density at STP? Whoops, if its density at STP is 0.901 grams per liter. So using that equation, you take 0.901 grams per liter, which equals molar mass times 1 over the 0.0821 times 273 Kelvin, which equaled 20.19 grams per mole. Number 8, let's see. Which component exerts the highest partial pressure? Using the equation of the XA equals NA over N total, you have 0.5 moles of H2 divided by the total, which is 1.47, 0.49 moles over 1.47, and 0.48 moles of CO2 over 1.47, 34, 33, and 32. 34 was the highest, so that had the highest pressure. Which of the following mixtures exerts the highest total pressure in a 5 milliliter liter container? So to figure this out, you would start by finding the partial pressure of each gas using the P equals nRT over V. Then add each of the partial pressures to find the total pressure, where C would have the highest atmospheric pressure. A 25-liter cylinder contains 3 grams of hydrogen gas and 14 grams of nitrogen gas. The first thing I did was write the Kelvin, so 298.15 Kelvin instead of Celsius, and then you need to convert the moles, so 3 grams of H2 times 1 mole of H over 2 equals 1.5, and then I got 0.5 for nitrogen, and then you divide those by the total. So H2 had 0.75 and N2 had 0.25. To calculate the partial pressure, you would take the P equals nRT over V. So for H2, 1.5 times 0.08206 times 298 divided by 25 liters equals 1.47 ATM, and then nitrogen would be 0.5 times 0.08206 times 298 divided by 25, which equaled 0.489 atmospheric pressure.